Okay, the next time you're outside on a clear night, do me a favor and just look up. You'll see stars, right? Maybe a planet. And if you're really lucky, you might even see the faint little smudge of a distant galaxy. It feels absolutely vast, almost infinite. But what if I told you that everything you can see, everything we have ever observed, is just the tiniest tip of the cosmic iceberg?
What if everything we think of as the universe, every single star, every galaxy, every planet, you, me, all of it, is just a tiny, almost insignificant fraction of what's really out there? Well, here's the thing. According to our best science, that's not some what-if scenario. That is the reality we live in. So check this out. This chart lays out the recipe for our universe, and it basically shows the staggering scale of what we don't know. See that tiny 5% slice? Ordinary matter? That's everything we know. Everything, from the smallest atom to the biggest star. The other 95%? A complete and total mystery. It's split between two things we call dark for the simple reason that, well, they're completely invisible to us. So today, let's go exploring in that mysterious 95%.
First up, we've got the universe's invisible scaffolding, the cosmic glue that's holding the whole show together. This is the incredible mystery of dark matter.
I want you to picture a merry-go-round spinning really, really fast. The faster it goes, the harder it is to hang on, right? Well, astronomers looked out at galaxies and did the math. They realized these galaxies are spinning so fast that all the stars on the outer edges should have been flung off into deep space ages ago. The gravity from all the stuff we can see just isn't strong enough to hold on. And yet, the galaxies are totally fine. Something else has to be out there providing the extra gravity.
So, to solve this massive puzzle, scientists came up with an idea. There must be some kind of invisible stuff out there, and they called it dark matter. As far as we can tell, it has one job: to act as that extra gravitational glue, holding galaxies together and stopping them from just flying to pieces. And the properties of this stuff are just bizarre. It doesn't give off any light, it doesn't reflect any light, that's why we call it dark. It seems like it doesn't interact with normal matter at all. In fact, right now, billions of these dark matter particles are probably streaming right through your body and you don't feel a single thing. The only reason we even know it exists is because of its gravity, like the way it can bend the light from distant stars. And we're not talking about a small amount here. Dark matter makes up a whopping 27% of the entire universe. Let me put that into perspective for you. For every 1 pound of normal stuff like us, there are more than 5 pounds of dark matter. It's the dominant form of matter in the cosmos. We're the weird ones. So, the big question is, what is it? We have a pretty good idea of what it's not. It's not made of atoms like you and me. It isn't any of the particles in our tried and true standard model of physics. It has to be something completely new, something that our current science has absolutely no explanation for. And that, right there, is a truly profound mystery. Which brings us to our next mystery, and believe me, this one is even bigger and, frankly, even stranger. If dark matter is the universe's invisible glue pulling things together, then dark energy is the mysterious force that's pushing everything apart.
You see, for most of the last century, we all figured the expansion of the universe from the Big Bang had to be slowing down. Gravity pulls things together, right? Makes sense. But then, in the late 90s, astronomers found the exact opposite was happening. The expansion is accelerating. Galaxies are flying away from each other faster and faster all the time. It's like something is flooring the cosmic gas pedal.
This slide just lays it out perfectly. You've got these two cosmic titans in a constant battle. On one side, there's dark matter, the glue, using its gravity to pull galaxies into these huge, beautiful clusters. And on the other side, you've got dark energy, the engine, this anti-gravity force that's pushing those same clusters apart. And just look at those numbers. Dark energy is 68% of the universe. It's completely dominating the cosmic tug-of-war. It's not even close. So what on earth is it? Could it be a fifth fundamental force of nature that we've just never seen before? Could it just be a property of empty space itself, that empty space isn't empty at all, but it's filled with this weird repulsive energy? Or could it be a hint of something even wilder, like maybe our universe is interacting with other dimensions? The honest-to-goodness answer is, nobody has a clue.
Okay, so dark matter and dark energy are shaping the fate of the entire universe. But our next mystery is all about its most extreme and frankly terrifying objects, black holes. These are the ultimate points of no return, where the laws of physics that we know and love just break.
Once you cross that line,
It's called the event horizon. Reality gets turned upside down. At the very center, the singularity, gravity supposedly becomes infinitely strong. According to Einstein's theories, time itself just stops. And the speed you'd need to escape becomes faster than the speed of light, which means absolutely nothing, not matter, not information, not even light itself, can ever get out. For decades, black holes were just a theory, a really weird prediction that popped out of Einstein's equations. Then, back in the 70s, we found some pretty strong evidence that one was out there. But the real game changer was in 2019, when the Event Horizon Telescope team managed to capture this image. It's the first actual picture of a black hole's shadow. It proved, once and for all, that these cosmic monsters are real.
So we can see the outside, but what actually happens on the inside? Where does all that stuff that falls in actually go? Do our laws of physics still work in there, or does something totally new take over? Does it lead somewhere else? It's a one-way door, and we have absolutely no way of ever knowing for sure what's on the other side.
For our last mystery, let's pull the camera all the way back out and ask what might be the most profound question of all. A question that's really about our own place in this massive, dark cosmos.
Let's just start with the sheer scale of it all. The latest estimates say there could be up to 2 trillion galaxies in the part of the universe we can see. No, that's not a typo, trillion with a T. Each one is a sprawling city of stars. Now let's zoom in a little. Just inside our own galaxy, the Milky Way, we think there are billions and billions of planets. A lot of them are about the size of Earth, and they're in that Goldilocks zone where liquid water could exist. So you multiply trillions of galaxies by billions of planets each, and the number of potential homes for life is it's too big to even wrap your head around.
And this brings us to a really simple, really stark, and honestly a deeply unsettling question that we call the Fermi paradox. The numbers, the probabilities, they all say the universe should be absolutely teeming with civilizations, many of them way older and more advanced than us. And yet, when we look out, we see nothing. We listen, and we hear only silence.
There are so many possible answers, and every single one is fascinating to think about. Maybe that jump to intelligent life is just ridiculously rare, and we're one of a tiny few, or maybe even the only ones. Or maybe the universe has only just now become a good place for life, and we're some of the first to show up to the party. Maybe they're out there, but they're communicating in ways we can't even begin to understand. Or, and this is the really chilling thought, maybe they're out there and they're watching, and they're staying quiet on purpose.
When you get right down to it, all of these mysteries, from dark matter to the great cosmic silence, they all have one thing in common. Every time we think we're close to an answer, we just end up with a dozen new questions. The universe does not give up its secrets easily.
But that's what drives us, isn't it? It's just part of who we are, to look into all that darkness, not with fear, but with a burning curiosity.
We come up with theories, we build incredible experiments, and we keep pushing the boundaries of what we know, always dreaming of what might be possible.
Because, maybe the greatest secret of the universe isn't what dark matter is made of, or what's really inside a black hole. Maybe the greatest secret is that there will always be more to discover. And the most important thing we can ever do is to never, ever stop asking why.